The topic of my today's talk is multi-party owners and address balances. But before we get to the actual talk, here's an important disclaimer. Everything that I'm talking about may not be true a month from now, like a few weeks from now. It just marks the general direction where we are going, but it's not necessarily going to be like I present today. But it's super, super important to know. It's super important to align on where we're headed, and it's really fun to see those features. So to correct the topic of my presentation today, it's imagining the future. And just like Stan, Kyle, and Kenny, we're traveling to the world of imagination. So the main way to represent shared state and to have any user interaction between accounts is to have shared objects. But what we ultimately want is to represent shared ownership. We want multiple parties to have access to to the same data, to the same state, and shared objects kind of do it, but we need to implement authorization, identification, and other models, the access control on top of it. And that's where the idea of a multi-party ownership comes from. So basically, we always wanted to specify some permissions, right? Because if you're implementing a shared object, you would need to have some capability that manages the shared object, this marketplace, like withdraw capability, admin capability, and something else. We want to actually be able to control read, mutate, transfer, and delete permissions. For example, the whole idea of kiosk is basically built because we want to set those permissions around NFTs, and we want the other party to define the behavior of the object. And if we just think in those terms, we can imagine the implementation of shared objects. We can imagine the implementation of single owner objects. So naturally, whenever we're thinking about adding a new storage model, we just add a new function to the transfer module, because that's where all the possible ownership models are. And it could be a multi-party transfer with preset permissions. But naturally, of course, we have the verifier rules. The typical public, not public, key plus store, or key. If we wanted to implement single owner model using multi-party permissions, we could just do it as, hey, a single user has all permissions, everyone else has 0 permissions. If we wanted to implement shared objects, and this is just an implementation of how shared objects could be implemented with it, it would be just everyone has basically all permissions for the object. So if you think about it, we have a couple special objects, maybe more, system objects such as clock and random. You cannot use them mutably because it's going to be blocking, we just disallow that. And with multi-party objects, you could technically imitate this behavior or have something behave like clock. It won't be as native, but it would be like it. So what could be the cases? Just the top 4 that I had on top of my mind while preparing the slides. It opens the door for new ownership models for NFTs, for RWAs. Maybe a creator maintains control, for example, to transfer something away or modify the NFT if the metadata got was set up wrong in the first place. Originally during Mint. Maybe games, for example, in the game that I'm building myself, it's often the case that I have one player, another player. I don't need anyone else to access the object. It's nice that both of them have access to it. So there's a lot of open questions. There's a lot of gaps in all of this. Naturally, there's question, how are we going to index them? Is it a shared object, or is it an owned object if you're a single owner? How much consensus, how it works, and so on and so forth, and how the authorization is going to work. So all of those are open questions. So please take everything that I've just said with a pinch of salt, and that's my favorite silver lining for everything that I say today. So another thing that we might improve is coin management. So coin management is one of those perfect things that we have on Sui, right? It's the thing that we used to promote the most. It goes nicely into function signatures. Something takes coin, and then you return a car purchase, like one of the most popular examples. And it's really nice, right? So like just when you go to the store and you have like just loose change in your pocket, you need to kind of like combine this change so you can make a purchase or just buy like a drink. And this is like a really, really nice model, which is very realistic. But
Yeah.
it would be really nice as well. I know that people who implemented coin management in this way or another, who know like what gas smashing is and other problems as we, or like spamming with coins, they actually dream of having a single balance for a single token, right? And it might be possible. So what if the balances were automatically merged per token type? Not automatically, but given certain conditions, that an address or an object could access its balance, and they're partying again. So what if there was a way to actually have a single balance instead of like having a bunch of coins? So basically, instead of coins, we just open a bank account and then we operate like this. So and the API for it could look like this. So again, not final, but at this stage, it looks like this. So we would add something of value t to an address, and I will explain a couple bits of here in a bit. And we would withdraw, given like certain parameters of withdrawal from an address, or from an object address. So withdrawal would look like a special call argument, just like object inputs or pure argument inputs. You would specify a special argument creating this withdrawal during the execution of the transaction. I'm just sorry. Every time I talk about execution or transactions, I look at these guys and I'm thinking like whether I'm getting something wrong or not. And we would naturally withdraw from sender. We just specify like, hey, I want to take 10 Sui from this address. Then execution is like, yeah, sure. And you get your balance out. So the reason why it does say T, it doesn't have balance T or coin T, and why the type, like the value you see there, is U128, which is very unusual for Sui, right? The coins are U64. That's the first question anyone coming from another network is asking. It's because this implementation actually allows, allows not just balances, not just coins, but like a lot of other use cases, given that the type it's operated on has a single field of some integer value up to U128. So, and the verifier rules, as you can see, the marked internal, require a custom implementation in the transfer. So we could implement something fungible called bebop, and we could transfer it and aggregate it on like a bebop balance, although it's not technically a balance type that we're used to. And this will be a very custom implementation. It won't support transfers, but for balance, it will. So if we're thinking about implementing a marketplace, or a city walk, using this model, like normally we would have a balance, right? So, and we inject balance inside an object, and then we can track it. So with address balances, we would be able to just add balance to the object ID. It shouldn't be ID to string. It's clearly ID to address, but my bad. But these approaches are not mutually exclusive. So first of all, with address balances, you would not be able to read the total amount, like the balance that you have on chain. You would only be able to request withdrawal, and during the transaction, we will know like whether you have enough or not. With the first approach, clearly you always know the balance. You can do something with the balance if it's 0 or something like that. So again, open questions. There is a talk of adding clawback or some features that would be friendly to regulators. The design is not final, so I'm just mentioning them because we're considering this, something similar to denial list, but maybe something more powerful. Again, depends on the use case. And how custom balances, like how custom structs non-balances would be treated like. So don't get surprised. It's just like a plus sign, crossed, and then an underscore. So the plus sign actually means the third topic that I'm going to be talking, just should mention, because we just today or yesterday we realized no one is talking about it, is that we are making significant advancements on the coin metadata front. So coin metadata was painful, and there's Bridger, my colleague, who is leading the charge. He's like, if you have any questions, please approach him. Coin metadata was a pain point for a lot of builders. What do I do with it? I accidentally froze it. I want to freeze my treasury cap, but I still want to edit my coin metadata. What if icon URL needs to change? Like I just moved my icon onto Vorus. For certain organizations, it's just not so great to have the same capability, which is crucial for their business, to also manage things that are less crucial, like metadata. And so Coin metadata v2 answers this specific request. Like we want separation of capabilities, we want a single registry which is well indexed, and we also want metadata to have markers for everything that is important for coins. In today's stage, although this feature is more ready than the rest of the features I'm talking about today, the metadata looks like this. It may have like slight adjustments, but as you can see, first of all, my favorite part is we deprecate URL. It's just like, it's the type and the module that we only use in one scenario when we create coin metadata, and then we never use it. I know it's minor, but this is my quite personal. Then we also mark if it's a fixed supply. How do we know if it's a fixed supply? Because you can actually unwrap your treasury cap and lock it inside metadata. So we know that, hey, this is a fixed supply currency, nothing can be minted, this is the supply that it has. We know if it's regulated because we know, there's a way to pass in deny cap or mark it with deny cap. So we know when a currency is, or token is regulated and has deny cap. We also know treasury cap ID. It's a pain point for a lot of applications when they want to find their treasury caps or find other treasury caps and verify security. So coin metadata effectively increases trust, increases level of information about coins and their state and the process under which they were published. And lastly, it opens up a door to potentially a new wave of coins. So we need types when publishing new coins. And for the longest time, we could not solve the problem of, hey, one-time witness may not be great for certain scenarios because, recap. There are two ways to create a coin today. One is using the balance create supply. Then you get then you kind of create the currency, you can mint coins, you can mint balances, but it's going to be without coin metadata. If you do it via one-time witness, so you publish a new module with a new type, then you get the coin metadata, then you get a single treasury cap, everything is fine, you get the standard currency. But if you want to create, say, an LP token on a pair of token A and token B, then you really don't have an option to get the coin metadata and also the benefits, the guarantees that this supply for this coin will be unique, because you will never be able to publish a one-time witness for it, right? And so for LP tokens case, dynamic creation is an important feature. And the way we solved it, or in theory we solved it, because it's not rolling out just yet, is how do we say that, how do we just differentiate between all coins created before and the coins created past the registry, is by adding a counter ability constraint, which is key. So we're used to T being drop, but this way we actually prove that we've shown an object, we registered its type, and then we deleted it, and hence we know that, hey, you own this type, and we've done it just once. So so registry and coin metadata v2 actually allows for that. So to summarize, new ownership models, there may be coming, or they will probably be coming, and okay, and they will unlock and they will open new types of applications on Sui, right? Because this is the change like this, any change in ownership, any new ownership model is a significant change, which basically just unlocks the whole world, the whole universe of solutions. Address balances solve a very practical issue, like coin management and aggregating balances. So basically coins, or balances in this case, start behaving like standard coins on other networks probably, or as people want them to be. But it doesn't discard coins. So coins will coexist and balances will just be, will have the aggregation ability. And lastly, coin metadata v2 is the feature that's coming very, very soon. will solve the indexing issues and increase trust in solutions and coins, and hence make certain scams or like potential vulnerabilities in implementations and indexers probably less likely to happen. This is it for me. Thank you for listening.